Good evening, friends. Today we are giving a lecture on optimal storage on tapes. Optimal storage on tapes is one of the application of greedy method. So greedy method is mainly used for obtaining optimal solution. What is optimal solution? Optimal solution is nothing but a feasible solution with the maximum or a minimum result. So in this problem, we have to find out all feasible solutions. Among them, which feasible solution has minimum retrieval time or a minimum access time, that feasible solution can be treated as optimal solution. In olden days, computer programs were stored on magnetic tapes. In magnetic tapes, we are storing n number of programs. So each and every program have a arbitrary length. So the sum of lengths of all programs is always less than or equal to the length of the tape. So suppose how to find out the retrieval time for access a particular program. So this can be calculated in this problem. Suppose there are, let n be the number of programs Li be the length of each program. So that is 1 less than or equal to I less than or equal to n. So the amount of retrieval time required to access a particular program Pj is denoted by Tj. So Tj is equal to sigma k is equal to 1 to j L suffix j, where Tj is the time required to retrieve a program Pj. So it can be denoted by Tj. Tj is equal to sigma k is equal to 1 to j L suffix j. So k is varying from first program to jth program. So up to this we are adding L1 plus L2 plus L3, that is equal to L1 plus L2 plus L3 up to Lj. So this is the minimum retrieval time required to access a particular program. Pj is denoted by Tj is equal to sigma k is equal to 1 to j L suffix j, that is equal to L1 plus L2 plus L3 up to Lj. So we are adding first program length plus second program length plus third program length up to jth program length. So this can be explained with one example. Suppose we can take a CD player. In this CD player there are 10 songs are there. Suppose we want to play a 9th song, so then the CD player can access the ninth song from the first song to ninth song. So that is accessing time for first song plus accessing time for second song plus accessing time for third song plus accessing time for fourth song plus accessing time for fifth song plus accessing time for sixth song plus accessing time for seventh song plus accessing time for eighth song plus accessing time for ninth song. So this is the total retrieval time. So that is T of 9 is equal to, example, so sigma k is equal to 1 to 9, so that is L9. So here n is equal to 10, so that is 10 songs are there in a CD. So we want to play a ninth song. So how much time it requires to access the ninth song is T9. T9 is equal to sigma k is equal to 1 to 9 L9. So that is nothing but L1 plus L2 plus L3 plus L4 plus L5 plus L6 plus L7 plus L8 plus L9. So this is the total retrieval time to access the ninth song from the CD that contains 10 songs. So in this way we have accessing a particular program among n number of programs. Then what is minimum retrieval time? So minimum retrieval time is equal to the average amount of time required to access a particular program. So that is 1 by n. So sigma k is equal to 1 to j, that is 1 by n, k is equal to 1 to n Lj. So that is equal to 1 by n of t suffix j. So this is the minimum retrieval time. Minimum retrieval time is nothing but the average amount of time required to access a particular program among n number of programs is nothing but minimum retrieval time. So it can be denoted by MRT. MRT is equal to 1 by n, sigma k is equal to 1 to j, L suffix j. So this term can be denoted as Tj. So therefore 1 by n into T suffix j. So this is the minimum retrieval time, and this is the amount of time required to retrieve a particular program. So this is amount of time required to access a particular program among n number of programs is nothing but Tj is equal to sigma k is equal to 1 to j, L suffix j. That is equal to L1 plus L2 plus L3 up to Lj. So for example, we can take ninth song among 10 songs. We want to access the ninth song. How much amount of time required? That is T9. T9 is equal to sigma k is equal to 1 to 9 L9. So that is equal to k is varying from 1 to 9. So k is equal to 1, that is L1, plus k is equal to 2, that is L2, k is equal to 3, that is L3, k is equal to 4, that is L4, k is equal to 5, that is L5, k is equal to 6, that is L6, k is equal to 7, that is L7, k is equal to 8, that is L8, k is equal to 9, that is L9. So the sum of L1 plus L2 plus L3 plus L4 plus L5 plus L6 plus L7 plus L8 plus L9, so is equal to the amount of time required to access ninth song. So what is the meaning of L1? The time required to access the first song is L1. What is L2? The time required to access the second song. Next, L3, the time required to access the third song. up to L9, the time required to access the ninth song. So what is the average amount of time required to access a particular program among n number of programs is denoted by MRT, mean retrieval time, is equal to 1 by n into Tj. So where n is the number of programs. So this is the description about the optimal storage on tapes. Next we can go for example problem. So this is one example problem. Let n is equal to 3 and L1 comma L2 comma L3 is equal to 5, 10, 3. So there are 3 programs are there. So first program length is L1, it is 5. Second program length is L2, it is 10. The third program length is L3, it is 3. Find out all feasible solutions and optimal retrieval order and optimal retrieval time. So for finding optimal retrieval time, first we have to arrange these 3 programs in several ways. So how many ways we want to arrange these 3 program lengths? So n is equal to 3, so that is 3 factorial. So that is 3 into 2 into 1. That is equal to 6 ways. So these 3 program lengths can be arranged in 6 ways. So among these 6 ways, which order has the minimum retrieval time, so that can be treated as optimal solution. So that is order. So there are 3 columns are there. First column contains the order. Second column contains the total retrieval time. The third column contains the MRT. So how many number of ways these 3 programs can be arranged? That is n is equal to 3. So 3 factorial. So that is equal to 3 into 2 into 1. That is equal to 6. So 6 ways we are arranging these 3 program lengths. That is 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. So orders are first program length is 5. The second program length, that is 10. The third program length, that is 3. So the pointer points to always to the first program lengths. Next, we can go for a second way. First program length, that is 5. The third program length, that is 3. Second program length, that is 10. Next, third way. Second program length is 10. Next, first program length is 5. Next, third program length is 3. Next, fourth one. Second program length is 10. Next, third program length is 3. Next, first program length is 5. Next, fifth way. Third program length is 3. Next, first program length is 5. Next, second program length is 10. Next, last order. Third program length is 3. Next second program length is 10. Next first program length is 5. So in this way we are arranging these 6 possible ways. Next, how to find out the total retrieval time. So first we can take the first program, that is 5. To access the first program, so we can require 5 seconds. Next, we want to access the second program. So to access the second program is equal to, we want to access the first program time plus second program time. So first program time is 5, second program time is 10. So that is 5 plus 10. Next, we want to access the third program. Suppose we want to access the third program, first we want to access the second program plus access the second, we want access the first program plus second program plus third program. So for accessing the first program, the time is 5. For accessing the second program, the time is 10. For accessing the third program, the time is 3. So this is for accessing the time required for accessing the first program. This is for time required for accessing the second program. This is for time required for accessing the third program. So that is equal to 5 plus 5, 10, 10 plus 10, 20, 20 plus 5, 25, 25 plus 10, 35, 35 plus 3, 38. Mean retrieval time is nothing but 38 by 3. Next, in this way, 5 plus 3 plus 5 plus 3 plus 10. Next, this way, 10 plus 5 plus 10 plus 5 plus 3. This is 10 plus 3 plus 10 plus 3 plus 5. And this is 3 plus 5 plus 3 plus 5 plus 10. And this is 3 plus 10 plus 3 plus 10 plus 5. So these are the 6 total retrieval times. Then find out the sum value. 5 plus 8, 13. 13 plus 8, 26. 26 plus 10, that is 36 by 3. Next, 10 plus 10, 20. 20 plus 5, 25. 35, 40, 43. Next, 10 plus 13, 23. 23 plus 13, 36. 36 plus 5, that is 41 by 3. Next, 3 plus 8, 11. 11 plus 8, 19. 19 plus 10, that is 29 by 3. Next, 3 plus 13, 16. 16 plus 3, 19. 19 plus 10, 29. 29 plus 5, so that is 34 by minimum retrieval time. So among these 6 possible ways, so which order has the minimum retrieval time? So that order can be treated as optimal order. So these all are 6 feasible solutions. Among 6 feasible solutions, which feasible solution has the minimum retrieval time? So that can be treated as optimal solution. So therefore, optimal order. So optimal order among these 29 is the minimum. So the order is 3, 1, 2. 3, 1, 2 with retrieval time so the optimal, these are the 6 feasible solutions. among which feasible solution has the minimum MRT value. So that feasible solution can be treated as optimal solution. So among these, 29/3 is the minimum value. So this is the optimal solution. The optimal order is 3, 1, 2. That is 3, 5, 10. So the optimal order is 3, 1, 2 with the retrieval time is 29/3. So therefore optimal solution is equal to 3, 1, 2 with minimum retrieval time is 29/3. So then we can go for another example problem. So next another example problem. N is equal to 3 and L1, L2, L3 is 4, 7, 6. Find out all feasible solutions and optimal retrieval order and optimal retrieval time. So there are N is equal to 3 programs are there. So how many number of possible ways? So 3 factorial is equal to 3 into 2 into 1. So that is equal to 6 possible ways are there. So N is equal to 3. So that is how many number of possible ways to arrange these 3 program lengths. So that is 3 factorial, that is 3 into 2 into 1, that is 6 ways. So how to write the order? So suppose 1, 1, 2, 2, 3, 3. So we can take first program, the remaining are 2, 3. We can swap these 2 and 3, so that is 3, 2. We can take the second program, the remaining are 1, 3. We can exchange these 2, 3, 1. Next we can take the third program, the remaining programs are 2, 1. We can exchange these 2, 1, 2. So according to these possible orders, we can arrange these corresponding program lengths. That is 1 is nothing but 4, 2 second program is nothing but 7, third program is nothing but 6. Next first program length is 4, third program length is 6, second program length is 7. Next second program length is 7, first program length is 4, third program length is 6, second program length is 7, third program length is 6, first program length is 4, third program length is 6, second program length is 7, first program length is 4, third program length is 6, first program length is 4, second program length is 7. So in this way we have to find out the total retrieval time. So that is, we want to access the first program, how much time it can take, that is length of the first program, that is 4 plus how much time required to access the second program, that is equal to access the first program time plus time required for access the second program, that is 4 plus 7. Next, how much time required for accessing the third program, that is equal to time required for accessing the first program 4, time required for accessing the second program 7, time required for accessing the third program. So that is 6 plus 7, 13, 13 plus 4, 17, 17 plus 7, 24, 28, 32. So 32 divided by number of programs is 3, 32/3. Next, 4 plus 6 plus 4 plus 6 plus 7. Sorry, 4 plus, okay. 4 plus 4, 8, 8 plus 6, 14, 18, 24, 31/3. Next, 7 plus 4 plus 7 plus 4 plus 6, 7 plus 11, 18, 18 plus 11, 29, 29 plus 6, that is 35 by 3. Next, 7 plus 6 plus 7 plus 6 plus 4. So 7 plus 13, 20, 20 plus 13, 33, 33 plus 4, that is 37 by 3. Next, so 6 plus 7 plus 6 plus 7 plus 4. So that is 13 plus 6, 19, 25, 32, 36 by 3. Next, 6 plus 4 plus 6 plus 4 plus 7. So 6 plus 10, 16, 22, 26, 33. 33 by 3. So among these 6 feasible solutions, which feasible solution has the minimum value? That feasible solution can be treated as optimal solution. So among these 6 feasible solutions, so 31 is the minimum value. So therefore, optimal order is 132 with MRT, minimum retrieval time, is equal to 31 by 3. So therefore, optimal solution is equal to 1, 3, 2 with MRT is equal to 31 by 3. So in this way we have solved. Programs are greater than 3, it is very difficult to find out number of possible ways. So suppose n is equal to 4, there are 4 programs are there, so that is 4 factorial, that is equal to 24 possibilities are there. It is very difficult to arrange 24 possibilities and find out the total retrieval time. So if the number of programs are 5, 6, 7, it is very difficult to find out all possibilities. So then we have another way to find out total retrieval time or optimal retrieval time for finding if the number of programs are greater than 3. Then we can do that problem. So this problem is mainly used for if the number of programs are greater than 4, then how to find out the total retrieval time. So this problem can be solved in this way. So suppose there are 8 programs are there. So it is very difficult to arrange 8 factorial ways, then it is very difficult to find out the total retrieval time. So at that time, so this problem can be solved in this way. First, arrange the program lengths in ascending order. So then 5, next 5, 7, 8, 8, 12, 13, 32. So after arranging these 8 programs in ascending order, this is the result. Then how to find out the total or optimal retrieval time? So that is equal to 5 plus, this is for accessing the first program, time required for accessing the first program. Next, time required for accessing the second program is time required for accessing the first program plus time required for accessing the second program plus time required for accessing the third program is equal to time required for accessing the first program plus time required for accessing the second program plus time required for accessing the third program plus time required for accessing the fourth program, that is equal to time required for accessing the first program plus time required for accessing the second program plus time required for accessing the third program plus time required for accessing the fourth program plus time required for accessing the fifth program, that is equal to time required for accessing the first program plus time required for accessing the second program plus time required for accessing the third program plus time required for accessing the fourth program plus time required for accessing the fifth program plus what is the time required for accessing the sixth program, that is equal to time required for accessing the first program plus time required for accessing the second program plus time required for accessing the third program plus time required for accessing the fourth program, time required for accessing the fifth program plus time required for accessing the sixth program plus what is the time required for accessing the seventh program, that is equal to time required for accessing the first program plus time required for accessing the second program, time required for accessing the third program, fourth program plus fifth program plus sixth program plus seventh program. Next, what is the time required for accessing the eighth program, that is equal to time required for accessing the first program, time required for accessing the second program, time required for accessing the third program, time required for accessing the fourth program, time required for accessing the fifth program, time required for accessing the sixth program, time required for accessing the seventh program, time required for accessing the eighth program. So this is for time required for accessing the first program, time required for accessing the second program, time required for accessing the third program, so time required for accessing the fourth program, time required for accessing the fifth program, so time required for accessing the sixth program, so time required for accessing the seventh program, so time required for accessing the eighth program. So sum of all these is 230. So therefore mean retrieval time is equal to total retrieval time 230 divided by number of programs. Number of programs is 8 programs. So in this way we have to find out the optimal solution if the number of programs are greater than 4. So in this way we have solved this problem. So previous problems and this problem is only for a single tape. Suppose there are more than one tape is available. So then how to find out the optimal order and optimal solution? So this problem is used for solving total retrieval time or optimal retrieval time with 3 tapes. Previous we are solving 2 problems. These 2 problems are used for finding total retrieval time with single tape. Now we have to find out total retrieval time for 3 tapes, that is T0, T1 and T2. How to assign programs to 3 tapes T0, T1 and T2, and how to find out total retrieval time in this problem. So here find the total retrieval time for the following programs with 3 tapes T0, T1 and T2. So the number of programs are 8 programs. So first, arranging these program lengths in ascending order. In ascending order. So that is 5, 7, 8, and another 5 is there, and another 8. Sorry. 5, 5, 7, 8, 12, 13, 18, 32. So after arranging these program lengths in ascending order, so these are 5, 5, 7, 8, 12, 13, 18, 32. Now we are assigning these programs to 3 tapes, that is T0, T1 and T2. So first program can be assigned to T0 tape, second program can be assigned to T1 tape, third program can be assigned to T2 tape. Next, fourth program can be assigned to T0 tape, fifth program can be assigned to T1 tape, sixth program can be assigned to T2 tape, seventh program can be assigned to T0 tape, and 8th program 32 can be assigned to T1 tape. Now total retrieval time for tape T0 is equal to, so time required for accessing the first program is 5 plus time required for accessing the second program is equal to time required for accessing the first program plus time required for accessing the second program plus time required for accessing third program is equal to time required for accessing the first program plus time required for accessing the second program plus time required for accessing the third program. Next, total retrieval time for tape T1 is equal to time required for accessing the first program is 5 plus time required for accessing the second program is 5 plus 10. Time required for accessing the third program is equal to 5 plus 12 plus 32. Next, total retrieval time for tape T2 is equal to time required for accessing the first program is 7, time required for accessing the second program is 13, 7 plus 13. So what is the total retrieval time? 5 plus 5, 10, 10 plus 8, 18, 18, 23, 31, 31 plus 18, 49. Next, 5 plus 5, 10, 22, 27, 39, 71. Next, 7 plus 20, so that is 27. So therefore the total retrieval time for 3 tapes is equal to Time total retrieval time for first tape 49 plus total retrieval time for second tape 71 plus total retrieval time for third tape is 27. So total is equal to 147. Then mean retrieval time is equal to, so total retrieval time for T0 plus total retrieval time for T1 plus total retrieval time T2. So therefore mean retrieval time is equal to total retrieval time for T0 plus total retrieval time for T1 plus total retrieval time for tape T2 divided by total number of tapes, that is equal to, so 49 plus 71 plus 27 divided by 3, that is equal to 147 by 3. How to assign these programs to T0, T1 and T2 tapes? This can be explained with the corresponding algorithm. Algorithm greedy optimal storage n comma k. Ascending order. Arrange the program lengths in ascending order. Next, n is the number of tapes. N is the number of tapes. K is the, n is the number of programs. K is the number of tapes. Initially, J is equal to 0. So this is tape number for I is equal to 1 to n. Do print assign program for tape G. Next, J is equal to J plus 1 mod K. So this is the algorithm for finding the optimal storage, finding the optimal solution if the number of tapes is greater than 1. So suppose the program lengths are 5, 2, 3, 4, 7, 6. So that is equal to, n is equal to 6 programs are there. Next, tapes T0, T1 and T2. First, J here, n is equal to number of programs, that is equal to 6. K is equal to number of tapes, that is equal to K is equal to 3. Next, J is in increasing order, that is 2, 3, 4, 5, 6, 7. So here n is equal to 6 and K is equal to 3. So algorithm greedy optimal storage. So n is the number of programs, that is n is equal to 6, and K is the number of tapes, that is T0, T1 and T2. How we are assigning these 6 programs to T0, T1 and T2 tapes? First, we are arranging the program lengths in increasing order. So after arranging them in increasing order, the program lengths are 2, 3, 4, 5, 6, 7. So here n is the number of programs, that is n is equal to 6, and k is the number of tapes, that is 3 tapes. First, in the first iteration, so j is equal to 0. J is nothing but tape number. So j is equal to 0, so that is 0th tape. For I is equal to 1 to 6, n is equal to 6, so I is equal to 1 to 6, print assign program I, that is nothing but I value 1, so assign program 1 for tape j, j value is equal to 0, assign program 1 for tape 0, so this is program 1, assign program 1 for tape 0. Next, j is equal to j plus 1, j value is 0, 0 plus 1, so mod k value is equal to 3, so that is equal to 1 mod 3, so 1 mod 3 is equal to 1. Now j value is equal to 1. Next, I is incremented, now I value is equal to 2, so j value is equal to 1, I is equal to 2 to 6. Assign program, I value is 2, so assign program 2 for tape j value 1, assign program 2 for tape 1, so assign program 2 is 3, it can be assigned to tape 1. Next, j is equal to j plus 1, j value is 1, so 1 plus 1, so mod 3, so that is equal to 2 mod 3 is equal to 2. Next, I is incremented, j value is replaced as 2 and I is incremented, now I is equal to 3. So third step, j is equal to 2, so I is equal to 3 to 6. So print 3 to 6 is true, so then the program enters into the loop. Print assign program I value is 3, assign program 3 for tape j, j value is 2, assign program 3 for tape 2, assign program 3 is 4, it can be assigned to tape 2. Next, j is equal to, j value is 2, so 2 plus 1, so mod 3, so that is equal to 3 mod 3, so is equal to 0. So I is incremented. Next, fourth step, so j is equal to 0. Next, I is equal to incremented I value, that is 4, so I is equal to 4 to 6. Next, print assign program I value is 4, assign program 4 for tape 0, for tape 0, so that is fourth program, it can be assigned to tape 0. Next, j is equal to 0 plus 1 mod 3, so that is equal to 1 mod 3 is equal to 1. Next iteration, now j is equal to 1, I is incremented, now I is equal to 5 to 6, now I value is 5 and j value is 1. So 5 to 6, it is true, the program enters into the loop. Print assign program 5 for tape j value is 1, assign program 5 for tape 1, program 5 is 6, so it can be assigned to tape 1. Next, j is equal to, so 1 plus 1, so mod 3, so that is equal to 2 mod 3, that is equal to 2. Now j value is equal to 2. Next, I value is incremented, I value is 6, so 6 to 6 do, condition true, the program control enters into the loop. Print assign program 6 For tape, J value is 2. Assign program 6 for tape 2. Program 6 is 7. It can be assigned to tape 2. Next, I is equal to 6 to 6. Next, J is equal to J plus 1, that is 2 plus 1 mod 3. So 3 mod 3 is equal to 0. Next, I value is J value is 3, J value is 0, and I value is incremented, that is 7 to 6. I is equal to 7 to 6. It is false, then the program controls goes to out of the loop. So then the program is terminated. So after assigning these 6 programs for T0, T1 and T2, this is, so that is equal to 2 plus 5. Next, 3 plus 6, 4 plus 7. So that is equal to 7 plus 2, that is 9. 9 plus 3, 12. That is equal to 11 plus 4, 15. So total retrieval time is equal to 12 plus 9, 21, 21 plus 36, 36. So MRT is equal to 36 by 3. So in this way, we have to find out the optimal retrieval time using greedy algorithm when the number of tapes is greater than 1. So thank you for watching this video.